Alright, so Venn diagram. So we talked about sets last session. Venn diagrams is a way of representing these sets. Yes, this is halfway through the booklet. So it's a visual way of showing a set. So you will notice that they will all have a box around them, and then they will have a number of circles inside. If there is one circle, it means it's just one set. Okay? If there are two circles, it means that there are two sets. These two circles happen to have an overlap. What did we call the overlap last time? Where the groups overlap. Had a special name. But the symbol was N, yes? What did that mean? Good, the intercept. Okay, so where those two sets meet is the intercept. Okay? These two groups, these two sets here obviously have nothing in common. They're completely separate to each other. Do you remember what we call it when one set is completely inside another? You're shouting out the letters that we talked about last lesson. Not E. The word begins with an S.
A-U-B. A subset.
Nice. It's a subset. Okay, so this means that it's completely inside it, and subset would be that C. Okay, so it's a squished C. So, as I said, there are lots of different types. Sometimes there's even three groups. Okay, so there are three circles that generally overlap. The most common that we're going to see is the two groups. So that's what we're going to focus on mostly. Okay, so to put values in a Venn diagram, first of all you need to look for the intercept. Okay, so you're going to... darn it, I should have got to do this one. Right, so here's my box. I've got set A here and set B here. Remember, my universal set is super important because they are the only numbers that we're interested in total. Okay? So we're going to first of all look at A and B. Are there any numbers that are listed in set A that are also in set B? 3 and 8. Okay, so the 3 and 8 are listed in both of them. Therefore, those are the numbers that go in the middle in the overlap. Does that make sense?
Yes.
I've labelled one circle A, one circle B. The labels just normally go to the top of it. Okay. Then what you're going to do is put the remainder of the numbers in each of the circles. So I'm missing 1 and 6. So the 1 and 6 go in this gap here in the outside part. That means that set A is represented by these numbers here, 1, 3, 6 and 8. So you just double check, do you have 1, 3, 6 and 8? Yes. Okay. Set B, we've already done the 3 and the 8, so we're now missing 2, 4 and 5, so they go on the outside. And this circle here represents set B, so you need to make sure you've got everything in there. Pretty straightforward?
Yes.
I've said the universal set's really important. Okay, the universal set, you need to make sure everything is displayed somewhere in your Venn diagram. And so what you then do is go through and say, right, I've got 1, 2, 3, 4, 5, 6. I'm missing 7. Okay, 7 is in my universal set, so that's why, I should put that colour. That's why the 7 goes in the outside. Now notice that 7 can go anywhere on the outside. It doesn't have to go right there. Okay, so the numbers on the outside are just what's left in the universal set. Good? Lovely. Are we asked to do anything? Illustrate the Venn diagram? No. Okay, lovely. Right, so then we're looking at this one here. Before you draw your diagram, you want to have a look at the numbers. So I can see that I've got 1, 3, 6, 7, 8 in set A, and 3, 6, 8 in set B. So actually, all of the numbers in set B are in set A. And that's why this one has been drawn completely inside it. Yeah.
Is that symbol an E? Or
That, which one has?
like at the top, given that blank? Like, what is that?
Oh, so this just represents a universal set. Okay, so it's a fancy pants E. So it's a big curly E that shows you it's the universal set. And so here it says that B is a subset of A. Okay, so B is a subset of A. So it's gone completely inside it. You're then going to put the other numbers just outside that circle. So we've got 1 and 7. So again, this circle here represents B. The big circle represents A. What's left are my 2, 4, and 5. So they go on the outside. And you should label the box somewhere with that E. Doesn't have to be at the bottom. I was actually covering up a different letter that's been used. Are we good with that?
What does the BCA mean again?
So this means subset. Now, it's got an extra line on it. Don't worry too much about that, but that's what the subset means. So B is completely inside A. B is a subset of A. Okay, good. Some special sets. Okay. Sometimes they will talk about your universal set and they will just give letters. I think we've talked about some of these in the past, maybe not very many. These letters here, the N, the Z, the Q, the R, etc., they are used to describe certain values. So N, if you see the fancy N, it means we're talking about natural or counting numbers. So it's a whole number that starts at 0. Okay, so counting numbers start at 0. So 0, 1, 2, 3, 4, 5, 6, and so on. Okay. Z represents integers. No idea why it's Z. The N sounds normal because it's natural numbers. Z is integers. Okay. So integers include 0, but they have positive and negative values. What's special about an integer? They have to be whole numbers. Okay, so we've only got whole numbers here. Z plus would just be positive integers. Z minus would be negative integers. Honestly, you lot on the roll. So Q, they're called rational numbers. Okay, so many numbers are rational numbers. It means that they can be written as a fraction. They don't have to be. But things like 4 would be a rational number because it can be written as 4 over 1. Okay? Even 0.3 recurring could be considered as a rational number because remember, have we been through that? Yeah, we did last year, I'm sure. How we change a recurring decimal into a fraction? No, we haven't done that? No, we weren't. We didn't do that? 100% sure? Okay, we're going to do that. R represents any number, any real number. Okay, so decimals, fractions, the whole kit caboodle. Okay, so R is any number. So just be aware that these things do come up sometimes. So for example, it may say that the universal sets are R. No, would they say that? They might. They might. Anyway, just been thinking about it. What did this E mean? Member of set. So would I say this is true or false? 2 is a member of Z. So what's Z?
Oh, integers.
So is 2 a member of the integer?
Yes.
So that's true. That was an easy question, yes? What did Q mean?
Rational numbers.
And what's special about rational numbers? They can be written as a fraction. We've got 2.5. Can that be written as a fraction with one number on the top and one on the bottom? So is that true or false?
What would be an example of something that could have been
Root 2.
Oh.
Because that goes on after 5. So there are very few numbers that are not rational. This, what does this say? 5 is not a member of Q. Is that true or false? False. Because it can be written as a fraction, yes? Oh, here we go. Pi is a member of rational numbers. Can pi be written as a fraction? No, so that's oh my head, hearing. And what was R?
Real number.
Real numbers. Negative number is not a member of the real numbers. That's false as well because it is. Why
Why is negative 2 not a real number?
No, Johnny, it is. Because this says negative 2 is not a member. So therefore, that statement is
How
false.
much is an odd thing?
Hang on 1 second.
She mentioned it.
Okay, there's an R different because there R includes decimal numbers as well. Z is just whole numbers. Okay?
Which ones are just
So just whole numbers are the counting numbers, so N and Z. Now rational numbers they can be decimals. Obviously 0.5 can be written as 1/2. Yeah? Ready?
What would be an example of a number that's not a real number?
Oh, we don't deal with them. So all of the numbers that you look at are real.
Great.
Okay? There are things called imaginary numbers.
But they, I don't want to think about it.
Alexis?
So, is all positive real numbers?
And includes 0.
So the decimals too.
No, sorry, they have to be whole.
So, and
N is the counting number.
Z plus R all have to be whole numbers.
R doesn't have to be a whole number.
And Z doesn't either, it includes decimals.
Z has to be a whole number. Z are integers. So just the N and the Z's.
Don't include decimals.
Correct. N and Z's have to be whole numbers. Right? We all got that sussed?
Yep.
I think is that it? Nice. Okay. So not got time at all. Let's go. So example 1, let the universal set be the numbers from 1 to 20 inclusive. So again, we always have to make sure we're defining our universal set. Set A contains even numbers and set B contains prime numbers. Well, here's the deal. Do we remember what prime numbers are?
Numbers that are only divisible by themselves and 1.
Okay, now I would prefer to have it as a prime number has exactly 2 factors. Because whilst what you said is correct, for the number 1 is itself, therefore people say, but 1 is a prime number because that follows that. But it doesn't, because it doesn't have 2 factors. Okay, so a prime number has exactly 2 factors, 1 and itself. Okay, so if we're given this question just at the top, the first thing we need to do is actually identify what those numbers are. Okay, so whilst even numbers would go on and on forever, we contain it by looking at just our universal set. So our set A is going to be the even numbers between 1 and 20 inclusive. So I've listed them here. Lovely. We're then going to list the prime numbers. Again, we're containing that between 1 and 20. So the prime numbers are these numbers here. Right? Now, many questions do involve things like this, probability, lots of things. So if you are not hot with your prime numbers, please make sure you learn them at some point. Okay, or be able to work out what they would be. Alright, so we need to fill in the tables into the value, into the diagram. What did we say we always start with?
Ones that go in the middle.
The ones that go in the middle. So, which numbers go in the middle?
2.
Just the number 2. Oh,
Can we just cross the middle?
if you want. Okay, so the number 2 goes in the middle. I'm going to label my set A and set B. I'm going to have my universal set symbol somewhere. So I've written that just on the top there. Everything else in set A needs to go in this gap here. I apologise, it's probably quite little for you. It's not massive for me. So I've got 4, 6, 8, 10, 12, 14, 16, 18, and 20. Then whatever's left on my B is going to go on the other side. So we've got 3, 5, 7, 11, 13, 17, and 19. Are we done?
No.
What do we have to do now?
Everything that's not
Good.
there.
Everything that's not there. So we're going to go through. Have we written 1 anywhere?
No.
So we're going to write 1 somewhere randomly in the box outside. We've got 2, 3, 4, 5, 6, 7, 8.
9.
9 is missing, so 9 has to go out here. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so they are the rest of the numbers. We are done. Sometimes you ask to describe what kind of numbers we're looking at. So obviously these numbers outside here are numbers that are not prime and they are not even. Okay, so these are the numbers that would be not prime and not even, or in other words, odd. Okay. So sometimes you'll be given the Venn diagram and asked to identify certain features. So here's my Venn diagram. We have to remember what this symbol here means.
Intersect.
Means intersect. So what does that mean? Where do we look at on the diagram? Where they meet, yes. And so this here would be this portion here. And remember when we're listing things, we use those fancy brackets.
Backwards U, do you mean again? And backwards U. Oh.
That's so not
What
backwards
they
you,
both have.
an upside down you maybe.
Yeah. Intersect.
It means intersect.
Which, what they both have. When I started.
Now, if it had said this, oops. What does this N mean?
No, it means the numbers.
Yes. So if you did a baby N and then C intersect D, remember this is asking you how many. So what would our answer be? 2. This is a side note. Okay, so it's nothing to do with the actual question they asked us. So when you see a little n, an actual n in front, it's asking for the number of elements in that group. Okay? So they may have put this bit in a bracket. So if you see n, it's saying how many things are there. Okay? So just be aware of that. It comes up quite a lot, and people get super confused with it. Alright, so the first one was finding the intersection. What did the U mean?
Union.
Union. So everything all together. So we're going to list every number we see in both C and in D. Okay, so we're going to list everything within the blue area. Do we label 1 and 64 twice?
No.
No, just make sure you only write them once. So, I'm lost my numbers. So, 16, 4, 9, 25.
What does that mean? I thought it had to be.
They don't have to be, I did say it's nice to be.
Yeah.
Shall we try and put them in order?
Down the
Yes, okay, let's try. Oops. Did I miss 64?
Yes.
Oh, Miss Harrison.
You mean this on 16?
Did I miss 16 as well?
Yes.
Oh, shush now.
Oh, I missed it too.
You do find people that hang out with me too much. Okay, are we good with that? Pretty straightforward. No, that I was going to say. Oh, now it's not one of the questions, but out of curiosity, do you recognise any of these numbers? Do you recognise what set C are? Put it, Jodie? Okay, set C. Yes, set C. They are all square numbers.
And D is multiple.
D is what, sorry? 27. Any suggestions on D?
Prime numbers.
Random numbers. They're the cube numbers.
Oh, I think that's a merit. They are the cube numbers. Emma said. I'm not sure we should be shouting too much about that. Okay. Do we understand what I mean by cube numbers, or what they meant by cube numbers? One times one goes one, two times two, two. Okay, très bien. All right, shading. Shading them. Sometimes you're asked to shade them. So either it's just a shading question, or it's you'll be asked stuff about it, and then you're asked to shade on top of the diagram. Okay, so shading. You're going to need a pencil. I would suggest always do this with pencil, because if you mess up, you can't unshade something once you've done it in the exam. You can erase it, but you can't unshade it if you've done it in pen. You can't use whiteout, so it's all of the exact measures. So, do not get freaked if you are asked to shade something and you are shading into another area that that you don't think that they've asked for. So, for example, here we've got our Venn diagram. They've asked us to shade set B. That means I'm going to shade everything that is involved in circle B. Now, I have happened to have shaded some of circle A as well, but I have done what they've asked me. I have shaded set B. You're happy with that?
Yeah.
Yeah? Now, the next one means what? Careful, what you get way on. Oh, union one. So A, union B. So what does that mean? All of it. All of what?
The whole
and B.
All both A and B. Okay? Be careful when you say one-time thing, because that means the whole box. Okay? So A and B. So we're going to shade everything in A and everything in B.
What if you color outside the line, guys? Erase it. Yeah, but what if you just leave it there? Is that fine?
And don't.
Well,
Be a rebel, just leave it there.
Don't. It's don't. I mean, I love it because you say what I want to say, but I'm going to say it a bit more tactfully. Try and avoid that. Okay? Jodie.
Does it matter if there's no differentiation between A and B?
How do you mean, sweetheart?
Like, when you try and do B one way and A the other way?
No, not when we're talking about A union B. Okay? Now, so whilst we know that A union means everything, I'm actually going to shade it, go back and shade this in a slightly different way, because unions are nice. They're great to shade, because literally you're going to shade whatever they've asked you here, and also whatever they've asked you here. If you've shaded something twice, it makes no difference, okay? Because it's just been shaded. So union questions, just take each of the things and shade them as they've asked you to. Intersecting ones are not quite so straightforward. But anyway, this is an A. Oh, what did this mean?
Not.
Not. So what do you think we're going to do here?
Everything's
Just
just
B.
Everything?
No A.
Be careful though. This is more everything, but not A.
Oh,
So this is where your everything comes in that this bit we would shade, sugar now, the outside of A. So all we're leaving blank is set A. Try and actually go up to set A. I mean, obviously my board's not
Oh, so
great.
we don't do the agents? stuff?
No, because that is in set A. Yes? So in a similar way to up here when we shaded set B, we did shade the intersect because that was in B. Here, we mustn't shade the intersect because that is in A.
Okay.
Does that make sense?
What is it?
It's because in that little intersection with A.
Yes. So in the real exam, I would totally do it pencil. I would suggest 90% of you are going to have
Okay.
a sufficient amount of time at the end of it. Maybe go back and do it in pen afterwards. Okay. But please do it in pencil to start with, because you don't want to be one of those people who are like, oh no, please mark this bit, not that bit, arrows here, there, everywhere. Like,
Just read through the whole thing and then.
well, that would be fine, but as I say, often it's just you're supposed to do it on the diagram they've given you, so, and sometimes there's already numbers in there, and it just, oh, pear shape, try not to. Alright, now, here we've got to be careful, because we've got intersecting going on, and we've got complements going on. So what this means is that we need to shade set B where it intersects with anything that's not A. This is a really common thing that you're asked to shade. So just be aware of that.
Can you just
It's
say
very common.
one more time, please?
So we are shading where B, set B, meets or intersects anything that's not in A. So this is one way of doing it. You could draw to the side little diagrams. Okay? This is my set A, this is my set B, and both of them. So if I'm asked to shade set B, that would be this bit here. If I was asked to shade not A, that would be that bit there. Agreed? Okay? So what we're doing is we need to shade where I would have shaded in both of them. So which area on here would I have shaded both of them? Be careful. It's just where I... No, I didn't say that.
Oh, it's just B. Just the B, but that's the intersect where they both.
Remember, we didn't shade the intersect here. So we're only shading the common areas that I shaded, but it's the common areas because it's where they meet.
Oh,
Okay? So the common areas that I've shaded in this diagram and this diagram would just be this portion here. Now, if you're sitting there going, yeah, okay, great.
I thought it would be outside. You said it's common.
But it's common because I didn't shade anything in the outside bit on this one. Okay? Now, drawing two separate diagrams is one way. Sometimes people like to shade one colour and another colour. Sometimes people can do it on here, but the tricky thing is if you do it on here, you have to erase everything that you didn't want. Okay? Now, that's why intersecting questions are a bit more challenging. Had that been a union, you would have just shaded set B and then also shaded not A. Okay? But intersecting questions, you've got to be really careful because you can only shade, or your final answer is going to be where they are both common. So if you were able to shade stuff and then erase it, that would be one other option.
So the first diagram you drew on the side on the right,
Yeah?
that was shaded B.
Yeah?
And the second one was
Not A. Because that's what my instructions are here, yeah? And so that meant the other bit. So as I said, the other way of doing it is to have just one diagram here, shade perhaps B in a stripe, and then not A in a different colour stripe. And you can see that the only part you shaded with both colours was that crescent. And so there are different ways of doing this, and everyone has their own preference. Okay, but the important thing is that you mustn't shade everything. So A intersection B, that should be a nice straightforward one. Okay, I hate to break it, but they're unlikely to ask you that one. Which bit do I do if it's A intersection? Just this bit here, yeah. As I say, this one is a really common one. Or A intersect, not B. Obviously, same in different grading. It would just be the crescent for A if it was that one. Okay? I think... so these are just some examples of them. These are the fancy numbers. Okay, so we've got outside here, we've got Q. So real numbers is our universal set. Q, what did that stand for?
Good question.
Rational numbers. So they're numbers that can be written as a fraction. Z was integers. Okay, so Z is any integer, yeah? N is natural numbers, so the counting ones. So the 0 and the 10 are obviously the only ones that are just natural. Then the -5 and -2 would go in the integer section. These ones would go outside here because they're not integers, and then anything else would be on the outside. I have seen questions that they've asked you to input numbers like this into the correct zone. Okay, so just be aware. That kind of thing. That's just another example. So we've got here, so in some boards they use U, so this shouldn't really use, so E, I should have changed that one. So here our universal set, and this is where you've got to make sure you understand what this means. So our universal set is between 0 and 12. Does it include 0 and 12?
Yes.
Okay, because it's got the extra line. Great. We know that they are Z, so they're just whole numbers. So they told us that A is 2, 3, 5, 7, 11. That B is 1, 3, 6, 7.
What's the
This is a member of. X is a member of the distance. So we start with our intersect. It's got 3 and 7. Fill in the 5 to 11, the 1, 6, 8, and everything on the outside. Okay, so that was just another example. Here are some examples of some shading going on. So the E is the universal set. That's the intersection, the union, complement.
Why is the universal set empty?
Because that's what's represented by the dots. Okay, and that means subset and empty set doesn't. Okay, and we'll do those after. Alright, let's get looking at some of these.